Lastly, I want to take a few minutes to talk about how to satisfy the octet rule with aluminum versus oxygen. So we know that aluminum, according to the periodic table, has a mass number of 13 a mass number of 26.98, which we're going to round to 27, and it has an atomic number of 13. Okay, so lithium's protons are going to be 13. Its neutrons are going to be 27 minus 13, or 14, and its electrons are going to be 13. When we look at this, if I was to draw out aluminum like we were doing in our notes, right? Aluminum in the center, and then we would have that first energy level, which would have 2 electrons on, and then the second energy level would have 1, 2, 3, 4, 5, 6, 7, 8 electrons on, and 2 plus 8 is 10, and then that third energy level would have 1, 2, 3 electrons on it. Okay, so that's what we know about aluminum, and that tells me that aluminum's number of valence electrons is 3. Okay, so now if I go over here and I look at oxygen, oxygen's mass number is 16.00. Oxygen's atomic number is 8, okay? And that tells me that the number of protons is going to be 8. The number of neutrons is going to be 16 minus 8, or 8. And the number of electrons is going to be 8 as well. So if I draw out oxygen, that first energy level is going to have 2 electrons, and the second energy level is going to have 1, 2, 3, 4, 5, 6. So now we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have what we're the atoms that we're working with. And then lastly, the number of valence electrons for oxygen is 6. Okay, so now we have that. So now when I go to draw these structures, as I did before, I'm going to come and redraw them with the knowledge of the valence electrons. So aluminum has 3 valence electrons, right? And fluorine has 6 valence electrons. Oh, not fluorine, oxygen has 6 valence electrons. Okay, and so if we go back to the electronegativity values, which is something that we need to think about here, aluminum's electronegativity value is 1.5, and oxygen's electronegativity value is 3.5. So that tells me that aluminum has less electronegativity than oxygen, which means oxygen is going to attract aluminum's electrons to it. And since oxygen needs 2 more electrons to get to 8, it's going to take 2 of aluminum's electrons. So 1 electron is going to come over here, and another electron is going to come over here, okay? So when we redraw this off to the side, I have an oxygen with 8 electrons, and 2 of them come from aluminum. But I also have 1 aluminum that has 1 electron, and we can't leave it like that. That's not okay. It wants to lose an electron, because what aluminum wants to do is it wants to go from 3 valence electrons to 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And so what it's going to do is it's going to transfer an electron to somewhere, and it's going to transfer an electron to a second oxygen atom. And when it does that, we have our second oxygen atom over here, which now has 7 valence electrons. But we have an aluminum atom with no valence electrons showing, and it lost 3 electrons, so it has a +3 charge. This oxygen atom has gained 2 electrons, so it has a -2 charge. Okay, so now I have this problem with this oxygen over here. It's not satisfied, it does not satisfy the octet rule. So I'm going to add another aluminum atom to this mix, and I'm going to show that this electron was transferred over here. So now I have my second oxygen atom now has that 8th valence electron, so it has a -2 charge. But I have an aluminum with 2 electrons, and we can't leave it like that, so we are going to add another oxygen. 1, 2, 3, 4, 5, 6. And we're going to show that this electron transfers over here, and this electron transfers over here. So now I have a third oxygen with 8 electrons and a -2 charge. But I also have a second aluminum with its 8 electrons, and it's having its +3 charge. So this is how we show that electrons transfer from a metal to a nonmetal, or when they transfer between atoms that have an electronegativity difference of larger than 1.8. And this is what we make it look like on the other side.